Siamo? Yeah. Ok, so oggi Scipy. Andiamo a linear fitting, ma we saw this with NumPy, so this will be very fast. But we'll see how to fit general function in a way, data interpolation, integration, working with image. We will have some fun here. Some physics constant and a couple of exercises to make here. Okay. So today will be short the lesson, but a little bit longer the exercise. Okay. So let's start with Scipy. That is the most complete scientific package, which includes LabPack, BLAS, or ODR, among others. That was used a long time ago by Fortran. Let's start by importing Scipy. So everyone, okay, import Scipy and see what is inside Scipy with, remember, with dir Scipy. Okay. So we have, for example, the discrete Fourier transform. Anyway, in the course, I think there is not any subject for Fourier transform, but if you want, I can make a. Okay, so I will add. Yeah. I think that the last day, because the last day.
It's possible two-dimensional, but anyway,
yeah, okay.
it would be okay.
Okay.
One dimension.
Ordinary differential equation also too, or not?
No, not
okay.
interested.
So first Fourier transform. Okay, I will prepare something for that. Okay, so we have something to integrate, to interpolate, for a package for any dimensional image, something for optimizing, to signal processing, as you can see, statistic function like a NumPy. Okay, and okay, let's starting with linear fitting. The best is very similar to NumPy. So for linear fitting, we can use for polynomial fit. We will use NumPy that we have already saw the last day. Okay, so that's not a problem. But let's see how to fit a general function. Okay, let's say that we have some complicated function and we want to make a fit. We are going to use a file that you can download, lesson 5 curve fit 1. Okay, everybody has that one.
No, io Scipy non ce l'ho.
Okay, download please the lesson classroom, because we are going to need to make our first fit to a function that must be known which function to fit. Okay? In this case, it's a Gaussian function. So the first thing to make a fit to a general function is to plot the result.
Ho capito bene, non c'è Scipy.
No, yeah, I'm waiting for that.
No, non troppo tempo, devo vedere come
Per installare con Python.
Ok, aspetta. So you don't have...
se
okay.
un po' rondoso.
It's con Spider.
Allora, sì, allora
Okay.
prima di quello Spider, poi vediamo già di
So let's download the file first and plot the what is inside the file to see what is the function that we are trying to fit. So remember, for reading, we are using log.txt with unpack true, so we can, because we have 3 columns in that file, x, y, and the error in y. So we can say unpack true and assign directly the 3 columns to the 3 variables, okay? With latex text. Because the first row is commented with hashtag, so there will be no problem skipping that. We don't need to say how many rows to skip. Is it plotted?
I need the file, just.
Okay.
No? Spider.
Sì, perfetto.
Quindi io da qui posso fare adesso.
No, non così. È fuori, è una termina.
No, lo può fare dentro Spider, lo può
Dentro?
fare. Funziona.
È
Spider.
Spider?
Da dentro Spider te lo
Perché
può fare.
fuori non lo so se me lo fa fare.
Ah, no.
Da dentro te lo mettere.
Aspetta. Questa
Sì.
sì.
Non sta
No,
scrivendo.
non sta. Prova P 3. Aspetta. Sì. No, non è proprio.
Fallo da dentro Spider, vedi se ti funziona anche.
Però qui sono già dentro Python.
Sì, digli pip, fai vedere cosa pip, se capisci. Via.
Sì. No, mai.
Solo pip, senza
Tu ce l'hai messo.
no, perché hai fatto un tappo. Fai via. Ok, metti punto esclamativo. Punto esclamativo 3. Vai, invia.
No, non riconoscibile. Come così. Project.
Aspetta, non si può più. Posso fare una cosa velocissima, sì, perché.
Io l'avevo fatto.
Aspetta.
Ah, no, aspetta.
Qua dentro.
Ci sta dentro?
Sì.
Così.
Questa è la
Ok, quindi pip lo capisce. Non è
Sì,
è pip.
è P.
Fai pip install e
Install.
Scipy.
No, con la I. Così. Bene. Via.
cosa sta facendo?
Sta facendo qualcosa. Ok.
No,
Ok,
No,
è install.
Install
Port Scipy.
allora, però se io lo faccio di qua, perché
Non lo so.
dovrebbe farlo, sì.
No, non è la I latina, non è
Sì, quello sì.
erroneo.
No, però se io
Python.
Se usi Python da fuori, adesso però devi uscire e rientrare dal Python.
Import Scipy.
ok.
Bene, perfetto. Allora, so the first thing is to load the file load, and for make the general fitting, we are going to use curvefit, okay? Which is a general fitting tool. So it works by minimizing the residual of by comparing the result with a residual function that we have to define, but it's the error function, and the error function is the function that we have to fit. In this case, we plot the function, and we see that it's a Gaussian, so we construct a Gaussian with all the 3 parameters that we want. In this case, we construct the minimizing function or the error function, Gauss fun. You can call anything with x, which is the independent variable, the scale, the zero, the mu, and the sigma. Okay. So we construct. This is a Gaussian function, and we want to try. We want to fit the values a, x0, and ss. That is to see what can we obtain.
So you have any idea why there is a problem with A? A equal that one too.
A equal. No. How did you import NumPy?
I did it.
But so ESMPX.
Sorry, what did you?
What?
E, what do you want to, what
There is
is
a
E?
problem with A.
Ah, A.
Sorry.
Sorry. So, I don't
No,
know.
it says there's a A.
Can assign to literal. Could you press A, enter? Ah, okay, so are,
No, there's
no, this the, this is not
the comma.
The comma is
Ah.
point, point, comma.
No, I don't understand.
Yeah, you are repeating this.
I'm doing exactly what is done there.
Oh, that's better.
But if I do A equal 10.3, that's no problem. But if I
No,
do-
just the comma. It's the comma.
Ah.
What's the comma?
Oh, but probably is it because it should be A, comma X, comma S, comma equal 10.3,
Yes,
and that's the
But,
syntax.
yes. Let me. I should work that. Has it been? I think that's been changed. Okay. A equal 10. Ah, okay, because it's on punti comma. Sometimes a typo there. Punti comma. Or
Otherwise, okay,
yeah,
will be the same doing. Okay.
or like this, okay?
Yeah.
So it's a typo, like this. Okay? So it's this. Okay, yes. No, but because this is not something that just to type, it's just show, okay? This is not how we should, you don't have to type this thing, okay? This is only to show the results, okay? You don't have to type this. This is only to show what are the results what the result should be.
Ah, okay.
So, okay, so everybody has the file, read it. So now, how it works? So we have the function, error function to minimize. Okay, this is our error function. Now we call curveFit. So we give our error function the name and x and y of our data. And if we want to weight the result with sigma, we give also sigma, the keyword, equal to the error, okay? That's it. So we will obtain the coefficients and the covariant matrix to obtain the uncertainties in the coefficients. Okay? So let's try to do that, and we try also to obtain these values without sigma, and we should obtain values close to this one for the scale, for the mu, and the position of the peak of the Gaussian, and the sigma of the Gaussian. Do we have values of that?
Sorry. Okay, so coef.
Coef is the coefficients.
It contains so
Everything that is not x. So in the function will contain in the same order that is in the function a, x0, and ss.
So this was already done the fitting.
Yes, this is the
Fit with the,
is fit.
and we
So the output
okay.
is that, and is fit.
Yeah.
So there are other parameters, for example, tolerance, or there are a bunch of parameters. I will show you how to work. So with the error in the coefficient is the square root of the diagonal of the covariant matrix for each one in the same order, okay?
Yes.
So,
Excuse me, I can
Should,
record.
now please plot the solution on the plot.
I have
okay.
this error because probably I thought this
Because
is my
sigma-
S, because
No,
I
because
wrote,
S is okay.
But
Okay, because
but
no.
I read the file, but
No, you didn't read the file again.
Okay. I
So-
have to read again.
You don't have to type this thing, okay? This is only for to show.
Yes, but I've already
Okay.
done.
Now, okay. You want to. Okay. now,
Again,
now,
the fit.
here, and now you can type coef,
Mhm.
and you will say values close to those ones,
Yes.
okay?
Okay,
Now,
thank you.
so overplot the solution, the fit on the data. So to see how good is the fit.
I can do like this,
That's perfect. Yes,
then
yes,
the
that-
coef 0
yeah, how do you
corresponds.
define x?
X, I mean, oh, okay.
It's better, yes. X should be a line space or a range between -10 and 10, something like that, okay? Because we are plotting a function equally spaced. Now that probably x is not ordered, so it's not a good idea to use the x as a plotting the x for the data as a plotting.
Scusami, Sebastian.
So define a new x with between minimum and maximum of the data. Okay, let's go. What is S? Could you plot? What is no S? What is S? Okay, see, that's okay. But okay. Okay, so x. Okay. Y. Okay.
Left.
It's okay. Seems. No. That's a S there. Something
Ah.
wrong there. Okay, it's a 2.
Ok.
Okay.
Termina
That's
il massimo, non
now.
proprio fare.
Have the function.
E quelli del plot.
Okay.
Fra meno 10 x, fra
Perfect.
meno 10
Coef,
10.
what are the result?
Ho scritto coef.
Perfect. This close to 10.3 minus 3 and
Questo il
1.5.
plot è...
Perfect. Now plot the data and the
dei
fit.
dati.
Esatto.
No,
Ok.
io il fit non ci sono
Ah, già,
riuscito.
bisogna calcolare il...
Il fit l'abbiamo già calcolato, il fit è
Sì,
in
esatto.
mi devo far fare
Ah,
il grafico.
perché non sei riuscito?
Ah no, non ci sto a fare il fit, no,
Ah,
a plottare il fit.
Ah, plottare.
Allora plotare.
Questa è la parte che
Devo andare avanti.
Cioè,
We
questo
can
non lo
plot with
devo
a
fare.
different color, so we can see how good is the fit.
Ma questo non lo devo
Quello fa il
mettere.
conto. Poi la parte che ti fa il grafico della
Questo
hostia,
qui,
perfetto.
inizio da qua.
Meraviglioso. Con error. That's wonderful. Sì.
Sebastian, may I ask?
Sì.
No, probably I need two parentheses here.
Yeah.
No. What's-
Division by 0. Okay, let me
No,
see.
no, okay, so
I'll
if
do
I
that.
do this,
Ex-
it doesn't plot. And so it says this.
Okay, let me check.
Because the Gauss fun needs two parentheses.
No. Okay, you can, for example, you can let. I'm going to show you. No, Gauss form is yes, it's the column is 2, but you have that. Yeah, you have that. Okay, you can use. You don't need to give coef 0, 1. Yes, asterisk coef. So it will give you everything by order.
Asterisk coef.
Yes.
Like this.
Yes, and remove all the thing
Like this.
like this. Okay, that's will show you. And okay.
But it doesn't.
Okay.
Oh,
Don't.
yeah.
No. Yes, this is showing something, but probably in a different
Because
one.
no, it's minus 10. 10.
No, it's okay.
here.
That's fine.
And the fit is also.
Oh, aspetta. Line space. This should be the number, not the step. This is because it's plotting nothing. Because
Oh, yeah.
okay, 200 or something like that.
Oh, okay,
Okay.
I see. Yeah.
Ah, perfect.
Grazie.
Nice fit. Okay, Anna.
No, I don't remember at all.
Okay, so now. So now.
Okay, just the
So
data.
just first define the this is the function. Yes.
Mhm.
So let me, for example, let's clear this PLF clear. So plot with error bar because we are
Così?
no
Click.
PL. How did you import how PL
Mm,
CLF
I think it was PLT.
CLF? Okay, perfect. Now plot this like an error bar.
Funziona, mica la pena funziona adesso. Sì.
Could you plot again or here did you use PLT, right?
Yes.
PLT.
Dot error.
Okay. plot. Okay, sorry. Okay, so now change that for error bar. Error bar, and now go here and say er equal no, e the y the epsilon. Er equal s enter s enter. Now you have to and now you can define a new for the fit. Let's say minus 10 line space and 100.
Okay, with the line space.
Yeah, just one thing. It's better for just to leave the spaces between this, just to be more clear.
Okay.
Line space. Good. And now the fit. Voilà. Perfect. Now the fit. Okay.
The minimum of x.
Yeah, minus 10,
Okay.
comma 10 and 100 points. So one thing that once you have the fit, that is going also to work with. For example, let's say that we want to call the function. Okay, we call this function with this coefficient. We don't need, if we have this in just one variable, coef contain a, x, and ss. Okay, we can call this function like this: gas fun, x, and asterisk coef. So this expands everything in coef. So you don't need to type coef 0, coef 1, coef 2, and so on. Asterisk coef. And we will go.
Always from the point on or
Qui.
if I need the
Qui vedi.
SS,
Io ho fatto così, cos 1 asterisco, io ho fatto poi F1, poi gli dicono F2, poi
just so
No, asterisk coef is everything.
on the left, on the right. Sorry.
Okay, you mean
If I have
give me
five.
an index? Yes, okay, you can do that also.
Oh, okay.
Because yeah, asterisk, it take asterisk 1, and then with the, it take coef 1, that means that leave 0 outside, and then expand. Yeah,
Ah, okay.
yeah, it works. It's very flexible. So, okay, how is it going? Anna? Okay, good, nice fit. Yeah? Perfect. Okay, so we know how to make a fit. So we have the error estimation of the uncertainties of the fit of each parameter to fit in the covariance matrix.
Wait a second, Sebastian. So in this way, with the module curve fit, is it a module curve fit?
Curve fit is a modulo of Scipys.
So I can fit any kind of function.
Any kind.
So I define a function, name
yes,
function with a
error
number
function.
of parameters. Then I.
We are going to make in the exercise there is another type of function that you should fit. So we are going to back to that in the
the
exercise.
arguments of curve fit. Just to understand, it's the first is the function.
The
arguments
first is
no,
the independent variable.
No. The arguments of curve fit.
Oh, the first is the function.
The
then the data we want to
X
fix.
and Y, and the
And
third,
then if we want to wait with the error,
then we
sigma
give what is it?
alpha.
Okay.
Well, there are more arguments to give.
Okay.
Then let's, for example, what if we want to give some estimation of the parameters? To be, for example, if our primitive go to minus infinite to infinite, maybe we want to go. We know more something about what is the solution, a range of value of the solution, and we want to give a guess. So it's very simple. We use P0 equal and the guess for each parameter. Okay? The fit will be faster and probably more accurate.
But it decides by itself the step of the
Yes, it's internally, but you can change that.
Okay.
And the tolerance of the error also.
Okay.
How many iteration by default is 800 iteration, but you can set up everything in the parameters. Just could fit question mark. So let's try to do this. The thing with this by saying, okay, this is my guess for the three parameters that we want to fit. Or you can give bounds, minimum and maximum. You can give a guess or a bound. Okay, so I will give you what is the minimum and maximum that I expect to change in the fitting parameters. Like this, bound is a tuple. The first one is the minimum for each of the three, and the second tuple is the maximum. Okay, so we can fit in this way. This is what I'm saying, that to plot is asterisk coef. So let's try with both to see how it works. So the plot, the result should be very close to the more accurate in this case. If we give the limits, the bounds, or a good guess, the result should be better. Okay. Do we understand this? What if we want to fit only a set of parameters, not all of them? Okay, we can say, okay, we know this parameter, and we come to force to the function that the first or the second or the third or a couple of them fix it, this parameter fix it, and the rest guessed by the function. This is done in this way. We are going to use a lambda function. I don't know if you are familiar with lambda function. It's like it's a function in Python that you define in the same line. So we will do in this way. Okay, if we want to fit A and SS, because we know the mu, we know one of the parameter, but we want to fit other two. So we will use could fit in this way. Okay, instead of giving here our function, Gauss thing, we give a lambda function that say, okay, these are the things that are changing in this function, and this is the thing that is fixed. And then we give this is the curve fit, this is the function now, okay? All this thing is the function. Lambda is a special function in Python that is defined in line. And we say, okay, lambda x, A, and SS are the things that change in Gauss form, okay? And we set up the other parameter, in this case the mu. And then x and y, which is what this curve fit is expecting.
Replaces something like a for cycle.
Yes, that's right. That's right. It's repeating the cycle. By itself, this is a function. Okay?
Instead you use a for, you use lambda.
Yeah, that's right. Lambda is something that is repeating in the cycle, and this is giving input to Gauss function. Gauss function, that is the function we have defined. So try to fit and see what is the result of A and SS.
And the algorithm that are used for fitting is curve fit. What that algorithm uses?
Inside,
yeah.
I think it's an error function with the least square. So you try to minimize, try to modify. I think it's a combination of Monte Carlo by changing all the parameters, the spatial parameter, and comparing the results with the error function.
Okay.
It minimizes the difference. So any function that we want to fit,
Okay, that's fine.
okay? So what is the result if you do this? It's more accurate for A and S's if you do it this way.
Well, in my case, within the errors, there's no difference.
Within the error, okay, yes. Because the other was minus 2.99 or something.
Yeah,
something like that.
yeah. And also no, but the other thing is that the others are the two coefficients. So the new and the error. So now with the constraint on x0,
Scritto questo devo scrivere questo.
these are the new coefficients.
Yes.
But the errors are like this, which
Okay,
is
so
about
it's
the same
very-
error.
Yeah, okay. Okay, so we know how
Da
to
qua?
use the same function,
Ah,
but
capito.
by fixing some parameters. Any question about this?
Ah, eccolo qua. Ok.
Okay?
Questo.
Okay, thing. That's phone, XASS, that's okay. Ah, lambda. You need to use, no, could fit, that's okay. Could fit, lambda, yeah, das ist ein Gauss function, x, 8 minus 3, that's okay, SS. Why? It's missing position argument, SS. No, because
Exactly.
I use have to choose 3 one.
I have the same error.
Try to disable this one. No, this is the
Oh, no, in the plot. The problem is in the plot, in the calling. Because now coef has only 2. So it's one missing that because you have fixed that. So you have to give
This.
coef 0, because this is in the middle, coef 0, the fixed parameter, and coef 1. Okay? Now the return is only 2 parameters, but the function is expecting 3. Is it working now? No. Okay. No, because no. Coef 0 is coef 0 only. This is, but you need a third one, which is the fixed one, which is minus 3 for the mu. This is 1. This is 2, but you need something new. Okay, so remove the asterisk of coef and give coef 0 there, because it's the first one, then minus 3, which is the one you have fixed, okay, and then coef 1. Okay, now. Okay, Now it's good. Should be to there. Yeah, good. Okay. Anna?
Yes. Just a moment. I inverted the
Okay. Oh, the order. So now you are getting a different
bad feeling.
couching.
Okay.
Italiano?
Ok. Allora,
Bene,
così.
perfetto.
Ok? Prof 0.
Così,
Ok?
così.
Prof meno 1
Yeah.
perché tanto è la busta.
Yeah, perfetto. Stanno qui?
Ok.
Ok.
This is
Perfect.
black
Okay.
one.
Nice. So let's go to the next subject, which is data interpolation. Okay. So we will use interpolate module from Scipy that contains interpolation routine based on the feedback library in Fortran. So this is interpolation 1D. So we import interp 1D from Scipy, interpolate like this. From Scipy interpolate import interp 1D, and we will need this to make the interpolation. This file, lesson 5 interp 1, x and y unpacked through, okay, with log.txt, and let's plot to see what are the shape of this data.
Non riesco ad importare.
No?
No, ho sbagliato qualcosa. Fallo uscire.
Oh, Scipy interpolate
Interpolate.
import interpolate yeah, okay. Interpolate. No, imp.
Ah, eccola là. Ok.
It's working? Something wrong there. No, this is not what.
No, yeah, clear this.
No, because you have to clear the
So, what?
PLCLF. PLCLF before plotting anything. Okay, nice. So it's interpolated. Okay. So how it's work? I'm going to explain. I'm going to explain this, and then you can type. Okay. So look at this first. Then you can write everything. So we read the data. We import interp 1D, which is a package of interpolate of Scipy, and we read the data from lessons 5, interp 1, unpacking through with log.txt. So the first column goes to x, and the second goes to y. And then we plot the data to see how it looks like. And well, we can use different type of interpolation: linear interpolation, cubic interpolation, spline interpolation also. So with interp, which is this one that we have loaded, we construct, this is a function, okay? This isn't doing nothing yet, just only creating a function that is going to interpolate linearly. If we don't specify the kind of interpolation, by default is linear. So to interp, we give our data x and y, and do nothing. This now is a pointer that is a function that is going to interpolate linear, because we don't say anything here. And then we create another one just to see the difference between linear and cubic interpolation, doing the same, x and y, but now we say kind of interpolation cubic. So now we have two functions, one to linear interpolation and one for cubic interpolation. So now how we obtain the interpolated data? So we need to construct the x, the independent variable that must be interpolated to obtain the y, okay? The dependent variable. So our x that we want to interpolate, our x position that we want to interpolate, we create a linear space between these two numbers because we know what is the minimum or maximum, what is the region that we want to interpolate, and the number of points. And now, how we obtain the interpolated data? Just calling our function for linear like this. We give here this one, or the QB in this one. So we now can plot this against this or against this to see the linear or the QB interpolation. Okay, so let's go. Okay, very nice, interpolated.
How may I clear the feature?
PLCLF.
Point.
Point CLF. And parentheses.
Ah, okay. Yeah, okay. That's it. Thank you.
Welcome.
Sebastian,
Sí.
going back to Corfi, in case I would like to fit here a function, say as a sinus, whatever, no?
Okay.
I can do like coef, cofmar.
First define the function.
But that's my question. Can I give you here a function that's already defined? Or
Yes, sure. Sure. Yeah, yes. It's something that is expecting some arguments to work.
So in this case,
You can give the NP cos or sin.
I can do coef, cov, mat, and equal and then sin, for example. NP.
Yeah, NP.
NP.
Okay,
sin.
but wait, because now it's not going to show you any. I mean, sin is expecting one argument, but the output is what you expect something that multiplies sin, or are you going to define offset in the? A phi.
Okay.
You know what is the? But maybe you can use a lambda for that. You can use a lambda there. So you say, this is the function a times sin. So you will obtain a on the back. Because only with sin, you don't obtain any, there is nothing to fit.
Okay, in this case, I need to fit something like sin alpha sin beta x.
For example.
Plus phi. Probably.
Okay, so
then I can fit the three parameters.
Yes.
Let me see if I understand the whole.
But it's, for example, for this is very interesting using the fast Fourier transform.
Yeah,
Because
that's
good.
good.
Yeah.
But I have a random.
Okay, so place the legend to see the difference between cubic and linear interpolation. So for the kind of interpolation that we have, we can use linear. That is by default. So we have linear, by default, nearest, zero, is linear, I don't know what is that. Quadratic, cubic, previous, next. Zero is linear, quadratic, and cubic refer to as spline interpolation, okay? So for spline interpolation we have zero is linear, spline linear, and quadratic and cubic are spline. Second or third order, okay. Or previous and next, just the nearest one. The previous or the next one. That's all the type of interpolation that we have, okay? We can also give bounds, like this. Okay? Everything clear? So let's go to integration. So, okay. Let's go to define. Okay, I'm not going to show how to do it, just do that yourself. So let's try to integrate this function. The first thing is to define the function. It's a user-defined function. So let's define a function that it will return this one. 2 times exponential minus x to the square divided by 5. This is our function that we want to integrate. Okay? So the first step is define that function. Definita l'utente. So what if you plot? Maybe it's not here, but should be very interesting to plot that function.
Which function exactly?
The function that
in fun.
Yes, the function that we want to integrate. Okay, so this is the function we want to integrate. Okay, so let's create that function first. This is the function that we want to integrate. Okay.
Okay.
No, this one. But 2 times this one. 2 times the exponential minus x to the square divided by 5. And let's plot that function. So give some values between minus 1,000 to 2,000, 1,000 minus 1,000 plus 1,000. and plot.
No, io sono ancora un po' dietro. Stavo portando l'altro.
Okay. It's not defined at the, maybe some mistake. This is not defined.
Ho sbagliato di nuovo.
Enter. Is different.
No, è dislessia. La funzione.
La funzione.
La funzione.
Ok.
Ok. Grazie la funzione.
Sì.
Così. Bene? Come la funzione? Remember to clean the previous interpolation plot. Yes, because of the range. But you can make a zoom now there
Yeah.
and see how it's already there.
But I didn't.
Very square. What's
No, because probably I.
500. Okay, because the number of points less than
Yeah.
very short. There is no problem to make a medium or something like that. And now, period plot. Have you defined x, the range?
No.
Okay, first define the range of values. Now it's working?
Yeah.
Okay, ahora con la nuova. Or you can use xlim, xlim to set up the limits. Much better. Okay, now we want to integrate that function between two limits. Okay? So for doing that, we use the package integrate from Scipy and the function quad. This is the function from Scipy integrate that make the integration quad. So from Scipy punti integrate import quad. How it works? It's very simple. Just the output is the integration and error in the integration. So we give to what the argument is the function that we want to integrate and the limits of integration. Okay? So let's call this one and see what is the result. Let's integrate this. Should be give something like that, okay? With the error. That is the result of integrate this function between -2 and 2 and the error. Is it working? Also, we can integrate all the function between -infinite and infinite. Just give the limits with numpy -infinite and infinite. And it will give you the integration of the function, the full integration. Okay? Is it working? there are several arguments that we can work with quad, like limits. We can. This is the limit of iteration. We can give some weights. This is list. What is this? Okay. So we can work a little bit with that. Okay. We can also have double integral and triple integral, but instead of using quad, we will use double quad or TPL quad, okay? Or any dimensional quad integration, okay? Fine? Okay, let's see if we go to work with image. Okay. Okay? So, to manipulate image, we will use the module ND-image from Scipy. We know how to read image and how to plot image, okay? Now we are going to learn how to manipulate. So let's import ND image as with an alias ND here from Scipy. Import ND image as ND. We are going to the color map from map.lib also, just to change the colors. And we are going to read Andromeda that we have already have from the other lesson, okay? And collapse all the 3 channels in Andromeda RGB channel to just one, to add together all the channels, to sum all the channels. Remember with sum, and we specify the axis where we want to perform the sum with axis 2. And we will obtain the image, the sum. That's the first thing. Okay?
Sebastian, we are using a JPEG image, but it will work the same with a FITS image, or it doesn't work with FITS?
Actually, it's the same because it's it doesn't matter because it's a matrix. If there is
so Scipy can handle with this different formats. FITS format.
I mean to read the the thing is that it doesn't matter because at the end you are working with this. Once you can read with that, and once you have this is a matrix, so you can do whatever.
IMLED reads
any
kind of format, like
FITS. Yeah, but be careful because FITS has an header.
Yeah.
So I think you need to specify something for FITS format. Let me see. In red. Actually, we have a better tool in AstroPy to read FITS.
Okay.
So this must be better.
Then we'll do
yeah,
it.
yes.
We don't need to do it now if we.
Yeah. Not so much documentation here, but let's try. No. Not in this case. Cannot find other. No.
Okay.
No.
Okay.
Doesn't understand FITS file because of the header part. Actually, all the image have some header just to that must be set up to let it know how to read it, but not for FITS. But we have AstroPy to do a specific package for FITS file. Okay, so we have now our image. Okay, so let's make some modification to this image. But it's already collapsed. Do you have the collapsed image, the zoomed image? So in shift, we shift the image. We say, okay, shift this image 50 pixels in one direction and 150 in the other. We give the tuple here, and the output keep here, storage here. Okay. This with like this to the empty, because now there will be empty. The size of the image is the same, but it's shifted. The empty pixels are filled with a constant value. Okay, which is estimated with the background or whatever. If we want to use a different field for the pixel, we can use mode equal to nearest. So it will fill with the value, the empty pixel with the closest one. Okay? A new create a new pixels that are empty because now the image is shifted.
There's also interpolation.
Something interpolation. Yeah, it's interpolation. Nearest in this case. Yeah, so we have for model we have constant, reflect, constant, nearest, mirror, wrap. That's a different type of interpolation of the empty pixel when we make a shift. Okay, so you can plot the shift 1 and shift 2 and see how it looks. You will see that now the image is shifted.
PL show.
Image.
PL.imshow.
So this,
L'argomento?
what is the shape of shift?
L'argomento IMG.
What is the shape of the shifted image? Is the same like the original one? What is the shape?
No.
No? Should be.
No, it's
Okay.
it's zoomed image. Why?
Yes, zoom is different
because
it's interpolated.
Okay, yeah.
Zoom, what is do is we are going to show you. Okay. Have you seen the new shifted image? No man. It's in a different. So you can copy there or just give it the path. Anna, you have that's the original one. Okay. That's the shifted one. Okay.
This is the second one.
Yeah. Okay, with the nearest pixel value. Okay, Anna? That's the original. Yeah, that's the shift. Perfect. Okay. let's make image interpolation.
Maybe it's the same question. Okay, but is it possible to apply this shift also to fixed images?
Yeah, but we have a specific package for that. It's much better, which is Astrofy fits in your fits.
So I can use fits as it is.
Yes, once that's to read fits, you can do that, and if you want to manipulate those things, once you have the data, which is a matrix, you can work with this. No problem. Because actually, what is important, actually, here we have using two packages. First one to read from matplotlib, and to manipulate the image and the image. So once you have the data, you read with fits or read with matplotlib, you can manipulate like this also, with interpolation, all these things.
L'effetto è solo che si amplia il...
Okay, now let's interpolate our image. This is made using zoom. So if we want to multiply by 2 the resolution, but interpolation, we use ND zoom. What is the image we want to interpolate, and the zoom, let's say multiply by 2 the dimension. Okay, and you will look now what is the shape of this one, the zoom image, compared with the original one. So the resolution, the resolution of the shape of is larger. If you plot the image, you will see the same image, but with the double number of pixels. Okay. Okay, we have. Okay, let's add some noise and blur the image. So first, let's copy our image and change the values to floats. Okay, so we can work better with that. So copy the image. And remember that to change the data type, we use. For an array, we should use as type. Okay, float.
How do I know the type of? It's a type.
Type, but you, for example, image, or 0, 0.
No, I have to understand what is the type of.
Yes, but now give the first element, for example, 0,
okay.
0 of image.
No, okay, img 0, 0. Like this, right?
It's
Okay.
a integer.
Integer.
Yeah.
But then it's noisy image. Okay. And
So
this change is needed because
we want to add some
special,
noise.
okay.
Yes, blurry. Yes. Okay. So let's add to our image. Let's add some noise. I have used this one. That means that. Okay, take this and add this. Remember this format, but you can use also this one equal to this one plus this thing, okay? But plus equal, that is going to add to this image, to this, what is going to be happen here, okay? So here with plus equal, we are saying, okay, take this image and add, calculate the standard deviation of the image, and multiply 0.5 by 5, and using a random standard number generator with this shape. Okay.
Shape is
the shape is yes. So it will create exactly the same size of image, and will add point by point, number by number to each position, each coordinates. It will add random. by adding this noise. This is the noise, okay? What we have here is noise based on the standard deviation of the image. Now you can plot before doing anything. You can plot noise image to see the noise that we have added. Okay, so we have the noise, Gaussian noise. Okay, Gaussian noise. Okay, so now we want to blur. So this is made using Gaussian filter. So ND, Gaussian filter, and we give the noisy image and the sigma. Now for noise we haven't used any package of ND image, just for NumPy. Okay, that's clear. But now for filtering the image, we are going to use Gaussian filter from ND image. What is the image we want to filter and the sigma? Or we can use a median. Let's create three of these. Okay. Okay, we can use a Gaussian filter, a median filter, or a VNR filter. Just using Gaussian filter, median filter, or okay, for VNR filter, we will need to import signal from Scipy, okay, because it's not in the ND package. So, and this is the size of the window. In the VNF, we give the blurred image and we give the size. That's a different type of filter.
Okay.
Okay, see that?
Wait.
Yes. No problem.
Fine.
Okay, first, we are applying any filter to the previous one created. Okay, so we create the blurred image by using a Gaussian filter on the noisy image. Then we create a median filter on the blurred image. Okay? At the end, we use a VNR filter in the median image. So we will have this four image: the noisy, the blurred, the median, and the VNR.
Give me an error.
Which one?
Oh. No module named NumPy testing decorators.
Which one?
When I try to import signal,
There's something internal. This one. Okay. Yeah, that's something with the package here. Probably with this is Spire.
No, it's
Oh, the-
Python 3 or in Unix.
Oh, you mean in Linux?
Yes.
In the a virtual machine. Is that the virtual machine?
Yeah.
Okay, so could you import? How did you install Scipy? Could you go to open a new terminal?
Sì.
File.
No, cioè ho fatto una volta, ancora non insieme. Tu, Ali.
Okay, so now try to make pip 3. space install Scipy space Scipy no Scipy no st remove no s remove that one s c'è Scipy SC no
SCIPY. Ah, ok.
Scipy
Ok.
update meno update meno 2 meno meno user enter remove update aspetta remove update
Allora io avevo portato con me, aspettate.
Sì, poi sì.
Allora NumPy lo mesmo same but instead of Scipy NumPy no, it's installed. Could you show me the error again? This one, the back one. This one. Back, up, go up. Go. Okay, stop there. Can you show me? Okay, let's go to remove the bulk package and start again. Go back to this here. So write pip3 pip 3 uninstall
Yeah.
the Scipy. Okay, enter. Yeah. Uninstall. Yeah. It's missing name. There. Yes.
Aspetta adesso.
No, the problem here.
Sono diverse.
Aspetta.
Macroscopicamente diverse.
What's
Beh, io non ho una differenza enorme.
Is
Because
Ubuntu?
when I try to import ND image, it's okay.
Yes,
But
yes.
Quello che non si vede, quello che non si vede è il...
But is this what distribution of Linux is this?
Fedora,
Oh.
Prima gli altri tre...
Should be what to have
Però non vedo la parte...
So let me check
Così
it.
non muovo.
Sudo DNF.
Cioè, prima gli altri tre si vede che gli altri sono blurred, cioè sono... blurred.
Torni a settembre.
Sudo.
Farlo
Ah,
fare.
no, ma si vede che sono... Cioè, tra la prima e gli altri tre si vede che sono...
Ma è uno schermo. È uno schermo.
Io sono lenta allora, non è uno schifo.
Cioè, a me mi
Tra
sembra.
la prima e le altre tre.
Ma la prima sì, è ovvio.
Allora che ne sto dicendo?
Ma io sto dicendo i 3 filtri che abbiamo applicato.
No,
Non ho capito a che serve.
la stessa cosa già.
No, ok. Che state to look like identical. No, forse ci sono delle differenze proprio.
Prova un attimo a cambiare i parametri dei filtri.
Dici? Ci proviamo che succede.
Uninstalling all.
Okay. Installing by using DNF, which is the general package. Are you connected to the internet?
Yes.
Okay.
It's okay?
Yes. Adriano, va bene? Questo è? Ok, allora.
Questi sono i 4 dal primo all'ultimo.
Ok. No.
No, no sì.
Pure io ho
Che
visto.
cosa?
Cambiando i parametri del version.
Uh-huh.
Sì, è una macchia prima.
Sì?
Sì, no. Cambiando il filtro.
Sì, la box.
Ok.
No.
Okay, now it will. Thank you.
Welcome. Okay, shall we stop a little bit?
Yes.
Bella questa. Questa è